Welcome to another video. Now, how do we solve for x here? So let's observe this one carefully. We are given cube root of 7 minus x equal to 11 exponent x minus cube root of 7. So how do we solve for x? Now, first of all, let's represent either this or that by a variable and let's see what happens. So let cube root of 7 minus x be t. Okay, so if that's the case, then in going back, this side will be t. So I'll get t equals to 11 raised to x minus cube root of 7. Okay, now because one side is t and the other side is x, it will be difficult to continue from there. So what we are going to do is to change this x here. So we know from here we can say that x is the same as cube root of 7 minus t. So x has gone to this side, then the t is in. So it means t is the same as 11 raised. So this is x, and we have x as cube root of 7 minus t. So that will be cube root of 7 minus t. So that is this. So minus cube root of 7. Okay. So guess what do you see here? We have this one in common, this and that. So they will cancel out. So this one cancel. So my next step will be t equals to 11 raised to minus t. As simple as that. Now, I would like to ignore this negative. So I'll go by this 1 on a to the power n, the same as a to the power minus n. All right. So it means t is the same as 1 on 11 to the power t. Okay. Now, from here, we can do cross multiplication. Okay, we can make this side over 1, then we do cross multiplication. So that would be t times 11 to the power t equals to 1. So we have this information here. Okay, now the next point is to observe this one carefully. Now what we've reached, the only way out is to apply Lambert W function here. So this side is t and this side is t. Now let's observe this. When we have m times e raised to m, and you take w function, the answer will be m. And also when we have e exponent ln of m, the answer is m. So we want to apply these theorems here. Okay, so from here we need to support this one. Okay, so instead of this, I'll make it t times, so e raised to ln of 11 to the power t. So remember this, that the answer is this. So in going back, this one will still give us this. So we have done nothing here. All right. So we have this one, okay, equals to 1. Now, when you have e raised to a to the power t, it's the same as e times t ln of a. So this side will be t times e, okay? This one come behind t ln, okay, of 11 equals to 1. Now, remember, we now have this one, and which has been achieved, e, or e has been achieved. Remember, we said this. So we have this one here. So this one is behaving like this m. Okay, left with this side. We have to make sure what is behind here is also the same as that. So something is missing here. Clearly, you can say that ln of 11 is missing here. So we need to balance it by multiplying both sides by ln of 11. So I'll multiply this side by ln of 11. So that will be t ln of 11 times e raised to t ln of 11. Then it will affect this one as well. So ln of 11 here. As simple as that. So from here, we can take w function. So since this side is the same as this side, we have w function of that ln of 11 e ln of 11 w function ln of 11. Okay, so from here the answer for the left hand side will be t ln of 11 because the w function of ln of 11. Okay, now remember we are after t here. Okay, so we can divide both sides by ln of 11. So my t will be w function of ln of 11 over ln of 11. Okay, ln of 11. All right. So we have t as that. So my t is this ln of w function of ln of 11 over ln of 11. Now let's observe the question carefully. We are after x, not t. So we have to do substitution. Remember that t is the same as cube root of 7 minus x. So let's bring back t here. So that will be, let me use this side. So that will be cube root of 7 minus x. So this is t, and this is t equals to w function ln of 11 over ln of 11 here. All right, so from here we can make x the subject. Okay, so that will be cube root of 7 minus, so this one will come in, w function of ln of 11 over ln of 11 equals to x. Okay, so if you want to probe further by finding the LCM, you can do so. But at the moment, I'll end here, okay, as the answer. All right. So subscribe to this channel for more updates. All right.